Welcome everybody to this session. It's a long walk up to here, so I'm glad you all showed up. I had a hard time finding it anyway, coming from the B building. And it's a good show up because this is not a really technical talk. I won't show any code today. I'll probably do that on Wednesday. Not really sure yet. Have to decide on that. But this is a talk about Agile software development. And it's actually a talk about Agile software development and things that can go wrong in Agile projects. Things that will go wrong in your Agile project if you don't take care. So first of all, by show of hands, who of you is actually in an Agile project or has been in an Agile project? Oh, that's good. I did the same in a conference 2 weeks ago in Brazil, and there were only 2 people that actually were in an Agile project. So I guess you're ahead of at least that people in Brazil. So, okay. Let's delve off. As usually when I do talks, I have too much material. Actually, I cut off half of the slides during the lunch this afternoon. So hopefully we will make it in 75 minutes. If not, this is the last talk of the show today. So I might end up ending at 6:30 or something. No, don't worry. So this is me. My name is Sander Hogendoorn, which is a difficult name to pronounce in a lot of languages. I work for Capgemini, which is a global consultancy firm. I think we employ about 110,000 people worldwide or something. I'm not really sure about the exact number, but my official role there is that I'm a principal technology officer, which sort of means that I deal with the innovation of software development in a lot of aspects. One of them being Agile, of course. I've written some stuff, some books, some articles, some columns, some blogs. And mainly this is the best way to find me through my websites or my Twitter account. If you have any questions directly during or after the session, send me a tweet and I'll try to answer that as soon as possible. There's also my email address. This is the more traditional way of getting in touch. So this is my data. Okay, so there's a lot of stuff out there that I want to cover today, and hopefully I will be able to cover it all during these 75 minutes. This is a lot of talk. At least I have to talk about Winston Royce. Winston Royce is a famous man in software development. I'll try to explain to you why that is, and why so many projects have gone wrong since. And it's not actually his fault, although a lot of people think it's his fault. I'll try to explain that. I'll do a bit about Agile, what Agile actually is, and what it's not. And some sort of a methodology comparison will be very lightly touched. Although I will not debate things like extreme programming or Scrum or any of the other Agile methodologies. This is about what Agile is, not what Scrum is or XP is or DSDM or FDD or whatever Agile methodology you're using. And then I'll show you a lot of stuff in different aspects of the Agile field in what actually can go wrong or what you might do to get your project a bit better. So let's delve off. First of all, we'll discuss Winston Royce. You know, Winston Royce, he worked for IBM, and he wrote a white paper, which is called Managing the Development of Large Software Systems. And he wrote this white paper in 1970. So that's ancient. And more or less as ancient as methodology papers go. This is the origin, well, let's say, of all projects that have gone wrong ever since. At least that is what a lot of people think. Why? Well, because there's a figure in the white paper, and that's this figure. And you have all seen this figure, of course. Did you? I suppose you did, yeah. This is the metaphorical image for doing waterfall-style projects. And it has a lot of stages in there, and all of these stages are handled by different persons, by different roles in your organization. And actually, it goes way beyond that, because this picture is actually the reason we have all these roles in these projects, in all these organizations, is because they were mentioned after these roles in this white paper. So there's people doing requirements, there's analysts, there's designers, there's developers, there's testers, and that's people taking the application into application management. These are the roles in this picture. And from that perspective, this is a very good picture. But it also has some drawbacks. First of all, since all these stages only happen once in a waterfall-style project, that means that people that actually perform this stage, they go out of the project after they're finished. And they're finished after delivering their milestone. And these milestones are really rigged. That means once you're done with the requirements, you've got them all, they're complete, 100%, which never happens in a project, of course, but that's the way these projects work. You go on to the next stage. People that have done the requirements leave the project, go on to another project. Why? Well, are there any project managers in the room? Project managers don't ever go to tech ed, of course, but and the same goes for testers, by the way. Are there any testers in the room? Actual real testers, not unit testing code writers, but oh, that's cool. Oh, that's good. Oh, very welcome to you. Now I lost my, no, it's all these different roles, and if you're a project manager, you might say, hey, this looks a bit like a Gantt chart, or since we're on a Microsoft conference, this is actually a Microsoft project planning sheet or whatever it is, with all the stages in between. And once you're done with your stage, well, you can get out of the project. But with people leaving the project, there's something that goes wrong. That is, you lose a lot of knowledge in the project. A lot of the knowledge actually sits inside of the heads of these people, not on the very big document they're writing. And you know, along these stages, the documents get thicker and thicker. And there's a lot of people in these projects actually only writing documents. And if you're an analyst in such a project, the bad thing about it is you don't learn from what you do, because you've left the project before the code gets written. That's the way these projects actually work. And so you don't learn from what you do. So there's people in projects that still do this. I've seen this about 1 or 2 years ago, that actually said there was an analyst. He came from a COBOL background, and he had to write an analysis report for a web project. And he actually wrote stuff in there like, if you press F2, the thing gets saved. F2 in a web application, you might be able to do that, but it's not the way you do that. So you don't learn from what you do. And further on down the road, every of these stages, there's no way of going back. In most cases, a contract gets signed with the company that starts building the software. That might not be the company that actually wrote the design. So you have to get it really fixed. That's the idea. And that's the way these projects work. You do everything only once. And the silly thing about it is, that doesn't work. We've seen this for 40 years now. Since the white paper came out, a lot of waterfall methodologies were written that actually use this picture as the basis. And it's not a very good basis. A lot of knowledge gets shifted. And, you know, if you're suppose you're an analyst, there's probably no analyst in the room either, but if you do that kind of work, the big question is, when are you finished? Ask the analyst in your current project, how far are you down the road? Is that like, are you 50% complete, or 80%, or 90%, or nearly complete? That's probably the answer you always get, but and it's very hard to estimate how long does it take, because you have to be complete. And if you're not complete, it's your fault that the rest of the project fails. And there's one other thing I'd like to mention about this picture, is that suppose you've written the application, and I've got an example that actually comes from a project about 10 years ago. We were doing a Power Builder project at that time. It's a long time ago, I know. And it was a Windows application. That's also a long time ago, of course. And what the architects actually did in this project is that when you were on a field, they triggered the business rules dynamically. And they did that when you moved to the next field. So they created the business rules, and well, they were fired, and everything happened. And then the whole code was done, the application was done, and it went into testing. And you know what happened with the testing? Is that the testers here, they actually had the same computers that the end users would have. And there was a difference in the computers that the developers had. They actually had an 8286 processor or whatever, and the actual users had an 8086 processor in their PCs, which meant that the application ran a lot slower. Which meant that every time they moved from one field to the other field, it took about 3 seconds. And if you're building a data entry application for insurance policies, that's not a very good thing. And so they had to redo a lot of the architecture, and they had to redo a lot of the code. And that's mainly because they started testing way too late. Of course, you're all in Agile projects, you don't do that. You test from day one, do you? Do you? Sure. You know, that is about acceptance testing, for instance. You can do acceptance testing within your iterations, but there's still about 40% of all projects that only do acceptance testing at the end of the project. Agile projects, I mean. That's not a good thing. You should start testing on day one. So this is actually what all goes wrong with the waterfall model. It's usually also fixed date, fixed price, and fixed features, and anything that can go wrong with that. So we shouldn't be doing this. And we shouldn't have been doing that for the past 40 years. Actually, if everybody would have read the white paper better, you would have seen that Winston Royce was a lot smarter than we expect him to be. Because there's a next picture in the project. That's not this picture. This is just a very bad example of a waterfall methodology. This actually comes from a company in the Netherlands. I won't mention the name because this is recorded. And this is their waterfall. It's a part of their waterfall style process. It actually has 14 quality gates. And there's about 150 different types of deliverables that get delivered. And these are all the roles that are important in the project, and these are the stuff they do with all these deliverables. You can imagine that any software development project using this approach at least takes 5 years. That's not a really good time to market, is it? So here's the picture from Winston Royce's white paper. This is actually the next paper and the next picture in the same white paper. And what he says here is that be aware that when you're in one of these stages in the project, that you always might want to go back to the previous stage. If you're coding and you discover new stuff or you discover new requirements or whatever, you might want to go back to design, maybe to analysis, and maybe even to requirements. And there's a very nice quote in the white paper, and that says, note that it is simply the entire process done in miniature to a time scale that is relatively small with respect to the overall effort. What he actually says here is that, yes, this is all the stuff you need to do in a project, but don't do it in a one trick. You don't do analysis just once because you learn new things during the project. And what he actually says is, yes, you need to do all this stuff, but in very short periods of time. As you all know, these days we call that iterations. Or if you're following Scrum, that might be a sprint. But it's still the same stuff. It's doing all this work in all these different roles in a very short period of time. And a lot of these short periods of time in the project. He wrote this in 1970. And the big question, of course, is, why didn't we have Agile back in the 70s? Probably because we weren't up to that. Probably a bit too hard to explain. Because waterfall is actually really easy to explain. It's not, you can say, oh, these are the activities, these are the stages, so when the analysis are done, they go off the project, and in come the designers, and when they're done, in come the developers. That's easy to explain. And also, a lot of the project managers in current projects actually came from this period. So they only have experience in doing waterfall-style project. So this will remain to be there for quite a number of years, despite of the fact that Agile is becoming more and more popular than we would ever imagine that 10 years ago. So, and then came Agile. Is this an evolution? No, it's an evolution. It's not a revolution. It's not that suddenly Agile was there. There were a lot of people in a lot of places in the 90s that started thinking about doing projects a bit differently. And in the end, about 10 years ago, some of these people came together and they said, well, we are discovering better ways of developing software. It's not that they said we have the final answer, because this has been 10 years ago, and this Agile movement has grown ever since, but it was already there. And they named it Agile, and they named it Agile 10 years ago. And this was more or less the basic stuff that they all agreed on, despite of the fact that they had different backgrounds. And they said, well, it's very important to have individuals and interactions. They actually do the work, and it's the collaboration that you have in these projects that is much more important than whether you're following process X or Y or Z, and having a certain tool set. It's not the tools that do the project, it's you who does the project. And they said, well, we're in these projects to deliver working software. Yes, documentation is important, but we do have quite a lot of documentation. As I've shown in the picture before, there's a lot of people in the project that just deliver documentation and who never get to see the working software. And that's a shame. And they said, well, it's far more important to be able to collaborate with your customer, actually to be collaborating with your whole team and everybody in the team, than it is to say, hey, we should negotiate this contract over fixed price and fixed data and fixed features and get into trouble. You know, I live in the Netherlands. It's not something I can help. I was born there. And there's about 8 law firms in the Netherlands that are specialized in failing IT projects. So I imagine in the US that there'll be there a lot more. I don't know how many, but a lot more. So, and then they say, well, there's value in the items on the right. Yes, some process is important, some documentation is important, but it all needs to fit in the things that we do on the left side of these equations. So that's the idea. And that's where the word Agile comes from. So that all sounds good. But the question is, what does that actually mean in my project? Where do I go from here? And, all these different Agile approaches, there's a lot of similarities in these approaches, and there's a lot of differences in there too. And I'll show you some of the similarities, and I'll show you some of the differences, because they actually do matter in projects. So a while ago, this Dilbert cartoon, it kept dropping in my email box. A lot of people were sending this cartoon to me, and it's a very good cartoon because it says, well, you know, that Agile stuff, it's just we just start doing stuff, and in the end we'll see what happens and what comes out, and well, we don't do any documentation, no testing, we'll just write some code, and that's not the way Agile works. Well, There's a lot of projects out there that actually do this, or more or less, and really haven't got a clue to what they're actually doing. But there's much more to Agile than just, well, write some code. It's actually, if you look at it, and it's a bit of a dirty word in this Agile community, the word structure. Structure is not something that a lot of people in the Agile community are really fond of, because it sort of reminds them into the waterfall era, and they don't want to do that. But it's very good to have some structure in your project. And again, Agile projects can be very structured. And this is all the basic set of values that you need to adhere to. It's about collaboration. It's about different roles working together, like the tester working together with your developer, the analyst, or the enterprise architect, or the different types of developers that you might have in a project. I finished a project last year, and we had 5 different types of developers. Yes, there was a .NET developer in the project. There were also Java developers in the project. There were SAP developers. SAP consultants were there. We had testers. We had a lot of different types of architects in the project. And all these roles have to fit into the project. And they all have some useful stuff to do in the project. It's not just having a developer and a stakeholder or a product owner and you can do your project. You can do that for certain types of project. But there's a lot of enterprise projects out there that it might not be enough. So there's different roles and they work together at the same time. It's not like in a waterfall process that the analysts come in and go out and the testers come in the end. Testers will be there from day one in a good Agile project. Although a lot of Agile approaches do not even mention a tester in the approach. They usually have a very limited set of roles, instead of having all these roles in there. So all of these Agile projects, no matter what Agile approach you're using, they all iterate. They'll use 2, 3, 4 week iterations. And I'm also always curious, who of you is using 2 week iterations in their project? 3 weeks? Oh, that's a lot more popular. And 4 weeks? Okay, so it's sort of mixed. Longer? Is anybody doing 6 week iterations? Or 8 weeks? I did an audit on a project recently, and they said, well, yeah, we work in iterations. I said, okay, how long are your iterations? He said, well, the current one is 5 months. And that sort of got me, and I said, well, the next iteration, how long is that? They said, well, 4 months. I said, okay, and the one after that, and I said, well, that will probably be 5 months again, and then one of 3 months, and then we're done. And I just couldn't figure it out. And I'll get to this anecdote later because it's in my slide deck somewhere when I talk about requirements. So they all do that. And they all apply a small unit of work. And this is really important because using a small unit of work will allow you to change them during the project. Say, well, I'm going to do 10 work items. Let's call them work items for the moment. I'm going to do 10 work items in the current iteration. And in the next iteration, I might do 11 or 12 or 9 or maybe even 10. So I can do multiple work items during one iteration, and I can actually finish them. And finishing means going through all the activities that you need to do to finish it. That is, do some analysis, do some design, do some development, or even code generation or whatever you do some testing, and get it delivered. And you have to define your done criteria for doing that. But you always apply a very small unit of work, whether that's a user story or something like a smart use case, or your screens or your web pages, or whatever you may choose, it's a small unit of work. And that's where this project with this 5-month iterations goes wrong. And what they also do is that in Agile projects, you'll be able to plan and measure continuously during your project. To be quite honest, I haven't checked this morning, but my current project is an Agile project, and we're in iteration 24 now, 2-week iterations. And we are sort of halfway through the project. And we go at a speed of, I think last time I checked, we went at 7.9 hours per smart use case point in that case, but it could also be a story point or whatever type of point you're using. 7.9, and we deliver about 25.4 of these points per iteration, which is a very accurate number. And actually, a lot of the other projects we're doing look at us and say, hey, you guys are faster than we are. You can actually compare these projects if you have the same unit of work, that is. And being able to do that also allows you to see, hey, there's new requirements coming along. What's the size of these new requirements? Can we actually fit them in? Or do we need to have additional iterations? Or is there a fixed end date to the project that we say, hey, sorry, we cannot fix it all, but you have to get some of the scope out of the project if you want to be able to deliver that on time. And this continuous measurement and continuous planning of these projects makes them really very good to plan or to handle actually, or to execute a project much better than a waterfall style project, where you only would be able to say, hey, we're now in design stage and we're about halfway done during design. That doesn't tell you anything about the remainder of the project. And that's a shame. And in an Agile project, you can always extrapolate and find out when the project would be done if you would continue at the current speed, the current velocity. So that's the difference. Testing is important. Well, a lot of these Agile approaches actually stress that testing is important, but they don't tell you how to do that. That's the difference maybe between something that might be called an approach, like Scrum, or a methodology. A methodology describes much more the things you need to do during a project. And there's a large community in the Agile community that says, oh, we don't like these methodology type stuff, but we want to have an approach and be as flexible and as free as possible. But it also comes with some drawbacks. So they always also deliver as early as possible. If the project I mentioned, with the Power Builder project I mentioned, would have done Agile development, they would have seen that the architecture failed during the first, the second, or the third iteration instead of at the end of the project. And that would have saved a whole lot of time. So, and the last thing, well, you know, communication, there's a lot of tools out there for doing communication in projects, a lot of complex tools. And Agile projects tend to use very simple tools, like putting up Post-its on a wall, or using an Excel spreadsheet for doing everything in the project. We use one Excel spreadsheet in the current project, and we've been using the same one for the whole year that we worked on the project. That's the only spreadsheet we have. And there's a burn down chart in it, of course, and there's some measurements in it, but it's really simple. When you get, by the way, into distributed projects, it gets a little bit more complicated, but that's also easy to handle. So that's the good stuff about it. You know, the stuff on the previous slide is actually, if you would ask me to come and have a look at your project to state whether that's an Agile project or not, I would say if you do these things, that's an Agile project. There's a lot of projects out there that say, like for instance, hey, we have stand-up meetings every day, so we're an Agile project. That's not true. There's a lot of projects that say, hey, we use iterations. Maybe they're 5 months or 6 months. That still doesn't mean by itself that you're doing an Agile project, because a lot of mistakes are made with planning these iterations. There's projects out there, and I'm not going to ask that, but that set out, that get the backlog in some sort of way, and then plan them out into all the iterations in the project, which means they will know exactly what they will do in iteration 34. If you do that, you lose all the flexibility that you have in the replanning process that you do each iteration. Because usually at the start of each iteration, you define what to do in the next iteration, not in the next 25 iterations. So there's some drawbacks in that too. But it doesn't mean that you're Agile by just doing that. Just using Post-its on a wall doesn't mean you're in an Agile project. Just writing user stories doesn't mean you're in an Agile project. You can do user stories in a waterfall project too. Might not be that handy, but you could do it. So, looking at these Agile principles, where does it go wrong? Well, there's a lot of stuff out there. I put this slide up this morning, and I just did a search on the internet. Actually, I didn't go any further than Wikipedia and the stuff that I already had in mind, and came up with this whole list of Agile approaches, and Agile methodologies, and Agile processes, or whatever you might call them. And there's a lot of them. And there's many more than you would actually need. And the big question is, which one do you choose? And in my personal opinion, you know, Scrum is by far the most popular at this time. It used to be extreme programming, and it will be Kanban in a few years, I guess. So people shifting through these methodologies. And it actually doesn't really matter, because the basic principles that I've shown you a few slides ago, those are the actual values that you need to apply. Those are the actual principles that you need to adhere to in your project. So whether you do that in Scrum or in Smart or in FDD, that doesn't really matter. There's differences in the type of work items they use, what you do in iteration, but these basic principles all remain the same. And to be quite honest, it doesn't really matter which methodology or approach you're using, because they're all similar in this respect. And there's some differences too, but the differences aren't big enough to make it work. So it's not the methodology, it's you that does the work and make the project work. So first of all, one of the let's say most popular Andy patterns that you come up with in Agile development is that I see a lot of requests for proposals from customers. Actually, you see a whole lot of these RFPs. And it's usually from customers that just start doing Agile development or thinking of starting doing Agile development. And out comes the RFP, and it says, this project should be done according to the Agile methodology. And if you see that in an RFP or in your own documents, you should immediately think, hey, these guys probably don't know what they're talking about, because there is no such thing as the Agile methodology. It just doesn't exist. Agile is a word that comes from the Agile manifest. That's the moment they thought up that word, it of course already existed, but using it in software development, that came up 10 years ago. But there's no such thing as the Agile methodology. There's a whole bunch of them. But this one doesn't exist. So note if you see these requests for proposals, the company that you start working for or writing the proposal for, they probably are not really aware of what Agile actually is. And that also probably means that they're not really aware of what Agile can do for them, or what it means to be doing Agile in projects. They probably went to a Gartner conference. The CIO probably went to a Gartner conference. This actually happens in real life. They go out to a Gartner conference and they say, wow, you should do everything Agile. And they come back and they say, hey, we're going to change this stuff around. We're going to change the whole company around. And that can be really big companies. And I've seen a lot of these examples in the past few years. And the CIO says, we're going to do everything Agile. And you see the whole workflow, and they haven't got a clue to what it actually means or why they're doing that. But neither does the CIO. So if you go into these companies, you will have to make really clear what the benefits and the drawbacks and the consequences are when you go Agile, especially in larger companies with large projects. So to stick with the Gartner analogy, this is one of my favorite curves in this trade. It's the Gartner hype curve. And it says these are the stages that a technology goes through until it gets mature. So first of all, there's a lot of hype. It's the technology trigger. And the hype starts to grow and grow and grow until we reach the peak of inflated expectations. I love this. And then at that point in time, adoption starts. And when adoption starts, and you might think, hey, Agile's been around for 10 years. That's really young in this field. You know, object orientation has been around for over 40 years. Actually, the first object-oriented language was similar back in '67. So it took a long time before it got mature, the object technology field. And it's out there now. Everybody knows about object orientation. And it took about 40 years. And with Agile, well, we're sort of in between 15 to 10 years old. And a lot of the companies that they have just read about it. So they haven't started doing Agile yet. So it's really young. And since there's a lot of demand about it, since we're on the peak of inflated expectations, that means a lot of people will go into the Agile field with no knowledge at all. And that's normal because that happens with all the technologies. And then we go down into the trough of disillusion. And this is where everybody starts thinking, hey, we're starting doing Agile projects, and they sort of fail. They're not the big success everybody says they would be. And you can do all sorts of things wrong that make your project fail anyway in an Agile project too. So we go into this trough of disillusionment. We'll end there up sometime. So there will be a lot of failing Agile projects in the coming years. And you can predict that easily from reading this graph. And eventually, we'll get out of it. We'll see that it's useful, and we'll see how to use it and to bring it to full productivity. But that will take probably, for most companies, another, let's say, 5 to 8 years. I don't mean to disappoint you, but it's actually, that will happen. So looking at this peak of inflated expectations, the moment where most companies will be here this year, or maybe next year, or maybe last year, we will see a lot of failure in Agile projects too. One of the things I usually see is that there's a lot of really lightweight approaches in Agile. And these lightweight approaches, well, they can be really good, and they work in a lot of projects. So I'm not debating the value of Scrum or XP or Kanban or Lean or Evo or Crystal Clear or whatever Agile approach you might use. But if you're into enterprise projects with a very large existing IT landscape, a lot of stakeholders and stuff like that, they might get a little bit too lightweight. And I've put up this picture. This is Icarus. He's a character from Greek mythology. And he was trying to escape a labyrinth, a very complex labyrinth. Let's say a waterfall-style project, for the metaphor. And so he built a really nice set of wings, together with his dad, who's up there. And really beautiful. And it worked. And they started flying with it. You know, and what they did is they finished it off with a wax layer. And they started flying, and the flying went really well. So they did a lot of good projects, and a lot of good Agile projects. And then they said, well, we can do anything with it. And they flew too high. And they got too close to the sun, and the wax melted. And they sort of crashed. And they were dead. And I'm not hoping that will happen to your Agile project, but it's the same analogy. There's really lightweight approaches that just might be a little bit too lightweight if you go into really large and really complex projects. And this is just an example. XP is an example. You know, XP has a very simple and straightforward process, and that works really, really well. It's also very developer-oriented, and it has a lot of really good practices. You know, test-driven development as a core value of a core practice of XP is really, really good, but it's not testing in a functional way. It's developers testing their code. And that's really good. You know, I'm a big fan of unit testing. We do it all the time. Well, yeah, we do it all the time. Most of the time. Nobody does it all the time, I guess, but we do it most of the time. And there's a lot of other good values in here, but it's a really, really lightweight approach. And the same, by the way, goes for Scrum. Scrum is also a very, very good approach. And you can do a lot of stuff with it. Actually, you know, I used the same approach when I moved from one house to another house 2 years ago. I had to deal with a new mortgage, get new furniture, get floors, do all sorts of stuff, and I put them just up as Post-its on the kitchen door of my old home. By the way, after moving, I forgot to remove them, so the guy that bought my house actually came in with a whole pile of Post-its after I was moved. And you can do that. And I had 1 week iterations that said, okay, what's the most important stuff that we need to deal with this week? Oh, we need to get the mortgage out there. So, okay, we'll put that on to-do. And next week, it's probably done. Well, doing your mortgage in a week, that's probably not likely. But so you can use this stuff and the same principles for a lot of different projects. It doesn't have to be really a software development project. It can be any project you do. And Scrum is a very simple approach to that. You have a product backlog with all the stuff you need to do. Those are the blue boxes. And when you go into a sprint, which is an iteration in most of the other methodologies, approaches, you split them up into tasks and you start doing the tasks. And at the end of your iteration, you have something that you might call a working product. And that's easy. And that's a very simple approach. And the big question in Scrum is, and also for the other lightweight approaches, where does architecture come in? Where does design come in? How do I get to the backlog? What's the role of testers in my project? And in lightweight approaches, you try to figure that out yourself. And that's okay, but not if you're an enterprise project. You might have some additional roles, additional people in there. So what's wrong with these enterprise projects? And they're the big SOA projects, or maybe even the big cloud projects. You know, I was doing some talks at an SOA conference 2 weeks ago in Brazil, and there were a lot of examples of really big programs that sort of redecorated the whole IT landscape of a company, of large companies all around the world. And these projects are really different. They have multiple stakeholders. I had the project that this picture comes from, it had 25 different stakeholders. And they all wanted something from the software we were building. It wasn't even an application. It was a bunch of newly implemented business processes that went through the whole IT landscape that they had. There's many different roles. There's much more roles than you would expect. It's not just having a bunch of .NET developers and a product owner and maybe a Scrum Master or a certified Pokemon trainer or whatever you might have. There's a whole lot of different roles out there, and I'll show you some examples from that too. There's a lot of external dependencies. For instance, this company depended on a number of other companies to provide services for the software they were building. And while they were building their software, these other companies were still working in a waterfall style process. And we said, well, we need this service right now. We need it in the next iteration, so in 4 weeks' time. You will need to deliver that service. And they said, well, that will take probably around another 6 months to do that. And then you get into trouble. And this happens in these large projects. There's a lot of change in requirements. You know, requirements change during a project. During a regular project, they change 20 to 25%. I calculated for my current project, and we're now at 12.7% requirement change coming from the original backlog. That's okay. That works fine. But in these complex projects, requirements change over and over again. It's mostly because you deal with departments that have the requirement for a really short time to market or great flexibility or change their minds every few weeks, like marketing departments, for instance. They're really well known for that. So you have a lot of changing requirements. And there's a lot of different types of deliverables in there too. It's not just building a web page. There's a service. There's a service that is not built in .NET, but that comes from SAP CRM. And it has a signature with over 40 parameters in it, of which I only know 2. And the other ones, who knows? Stuff like that happens in these projects. So it's really complex. And they have really complex landscapes. And this is an example. This is an example from one of my customers. And each little rectangle in this diagram is actually a system. And this is only their customer service department, which is sort of a quarter of the whole company. And this is a large international company. And for instance, this little pink square here is SAP CRM. Just to give you an idea about the size of this landscape. SAP CRM in this installation, it has a lot of tables in there. Well, it has many tables. How many do you think it has? Just by guessing. 5,000. More. Tables. I don't mean records. Tables. Go up. Okay. You're never going to guess. 142,000. That's just this little pink rectangle in this diagram. And any business process they implement goes right through this landscape. And they're working in a quarterly release. And to get the release out, it takes them to test the whole release and the integration stuff. And it takes them about 4 weeks of every 13 weeks that they have. That's a large portion. And that makes it really complex to do these projects. So you might say, okay, if I do these projects and I want to do them agile, because you want to do that, you might do some additional stuff. Like, for instance, focus on the fact that there's different types of iterations. Like the fact that you work in releases in your project. And that projects might run longer than just 3 months or 6 months. Or how to get to the backlog. How do you get to your backlog anyway? It's a bunch of user stories. People write it out on Post-its and they put it up on the wall. In these projects, that will not be a very good technique to do that, because it will lack the structure and the reuse that you see in these large projects. So you need some sort of additional way of doing requirements, a bit more structured. And software architecture, for instance, you need to have some attention to software architecture. It's not just say, oh, we'll discover the architecture during the project. That might work, but not in this case. These projects are far more complex to do that. And testing, well, testing a service that is created and realized in SAP takes a whole different approach than just, hey, we're going to write some unit tests in C#. There is no unit test environment in the SAP development stuff. How do you write unit tests? There's no unit test there. We can write unit tests in C# or in Java or in VB or maybe in whatever JavaScript language you use, but not in SAP languages. There's no way of running that stuff in a test environment. The development environment for that just doesn't have it. It's not Visual Studio, you know. It's not even Eclipse. It's well, different. I can tell you it's a lot different than what you might expect. And deploying this stuff takes weeks. It's not just pushing it out there and we have a new version out there every 2 weeks or every week or whatever we do in Agile projects. It takes weeks. So you have to take that into account when you do these projects. And that makes up for a little bit more process in your Agile projects. I'll give you some examples of approaches that do that. This is an old one. This is called DSDM. It actually comes from the UK. And there's something interesting about this approach. And it has some small stages in here that says feasibility and business study. They're actually paying attention to how to get to the backlog. Actually, in DSDM, it's not called a backlog because it's older than the word backlog is. So they use a prioritized requirements list, but it's the same as a backlog. And they have ways of getting there. The same goes for FDD. Feature-driven development is another Agile approach that adds a bit more structure to what you might do during projects. So they said, develop an overall model. And the overall model actually is your backlog. But there's ways of doing that. There's diagramming techniques for doing that, like use cases and class diagrams and whatever you might want to do. But they have a way of getting to the backlog. And that's different from the lightweight approaches. I'll show you another example because this is the one we're using in most projects. It's an Agile approach called SMART. It's not a really good name for it. I'm one of the authors of the approach, but back in 1998, I think it was, this was the first word that came to mind. Not a really good word for an Agile approach, but the same goes for extreme programming. There's not a project manager that says, hey, we're going to do extreme programming. They will really be scared of that, for no reason, by the way. But so we say, well, there's different types of iterations in a project. Like, there's iterations that help you get through the backlog using some modeling techniques, which we call smart use cases, which I won't delve into much today, but I'll do that on Wednesday. And there's iterations where we build the software. And there's iterations where we sort of stabilize the software. We try to get it all together, group it, and do some integration testing and get it out to the end users and say, hey, if this is the stuff that we would put in production, would you be able to accept that? Would that be okay? And if they said okay, well, the finalized iteration is successful. So in larger projects, for instance, in my current project, it's a project that will have around 60 iterations. And if you do that, you will need to focus on doing sub-releases or releases or whatever you're going to do. It's not just have a whole bunch of iterations or sprints or whatever you might call them, and at the end we'll deliver some software. You're not going to do that. You want to put it into production or put it into a production-like environment much earlier, because you also want to test that, and you want to give the end user also their value for that. So there's a lot of this smaller stuff that comes out. We say, well, in most cases we work in sort of sub-releases, like there's a number of these realize iterations. You can do that in Scrum as well. Just name them differently. And at the end of this iteration, we'll put out a sub-release, which has a portion of the software implemented. And then you go into the next sub-release and the next sub-release until you're finally done and get it into application management. So having more types of iterations and thinking about what the focus will be in your iterations will actually help you do these larger projects. Not just building stuff right out and putting it out in the end. That will be much more waterfall, I would say. So how do you deal with requirements in these projects? Well, there's the user story, of course, and these are in Dutch, are they? Yeah, they're in Dutch, which is a really easy language to learn if you know it. And I'll put up some ones in English too. User stories are usually structured like this. Like, as a customer representative, I can search for my customers by their first and their last name. That is a requirement of your system. But it's also, if you have a whole bunch of these user stories, it's also highly unstructured. If you do these complex projects with implementing complex business processes and you have to be very sure that you get everything, this might not be the right level of structure for your requirements. You might do some additional stuff in there. And then there's a lot of people that say, hey, you know what, we'll go start use cases. We'll start using use cases. And use cases is it's a very good technique. Actually, the way a use case is described adds a bit more structure to what you would use for your requirements. A bit more structure than you would usually do in user stories. Of course, there's attempts being made of adding more structure to the user stories, like using epics and different layers and different sort of hierarchical approach to using user stories. And that helps too. But there's a lot of people doing use cases as well. By the way, just another example of a complex project. This is a web shop we built a few years ago. This diagram, it depicts all of the different ways that the customers, this is a company that sold software to universities and colleges and schools and elementary schools or whatever. These are all the different ways people can authorize for the application. This is just logging in to this application, which means it's a highly complex application, and it actually was. So we used to build that not by using user stories. So in come these use cases. So what's with the use case? A use case is usually described in a very structured way, like it has a name and a goal, it has pre and post conditions that form sort of the contract you have with your use case. So if I make sure this is done, what do you do for me? And in the end, the use case delivers, and that's the post conditions. And it has a basic flow. Like, if you take these steps, you will end up at the positive result. And it has alternative flows. That means if I'm in step 3 and something else happens, I might go into that direction. That's called an alternative flow. And alternative flows usually go back to the basic flow or go back to the alternative flow that was calling this alternative flow, etc., etc. And that's where it starts to get complex. If you look at a traditional use case, the big issue with them is that they can either be really complex and really big, and they can be really small. I was once doing a project for a Dutch pension fund, and they had a use case that was named Do the Quarterly Billing. And out came 1.3 million bills, I think it was, something around it. And another use case in the same project was a use case called Login. They were not actually on the same level. Actually, they were, but the way they were described was totally different. The example I've got here, sorry, it's in Dutch again. I won't translate it because it's too much work. And this particular use case came out of a project with a large bank. And the use case description for this use case had 65 pages of text. That's one use case. That was the project that had an iteration of 5 months. They were actually implementing this use case. And it took them 5 months, at least they thought. It actually took them 8 months when they were finished. And this use case of 65 pages, it had 12 pages of basic flow. That means you had to go through 12 pages of steps before you reached the positive goal. And that's quite a lot. If you're a developer in this project, well, that was a hard job. The people that were in the project weren't really happy with these use cases. And even more, it had over 100 alternative flows. And if you're a tester, you know that you have to get out all these scenarios and test all these scenarios and write test cases for them. That's a lot of work. If there's 100 alternative flows, you might end up with, I don't know how many scenarios, maybe 1,000 or maybe even more. And that's impossible to test. So these traditional use cases don't work really well. And they particularly don't work really well in Agile projects because they're too big. It's not really, you don't become really happy from implementing something that at the end of iteration you might expect, hey, we've finished some stuff. But if you have these use cases, these really huge cases as I call them, that takes about, I don't know, 6, 7 short iterations or iterations of 5 months. And iterations of 5 months, of course, are not good because your feedback cycle is way too long. That's why we have short iterations, to keep the feedback cycles really, really short. So we ended up with doing a different style of use cases, and I put up, especially for you, Lauren, I put up when it's on Wednesday at 10:15. I'll talk about these use cases much more. And what you see here is a whole bunch of use cases. Each oval in this diagram is a use case, and I have some examples of it. And I won't tell you now how to get to these use cases. I'll do that on Wednesday. And we go one level deeper with modeling these use cases. And if you do that, they end up really being really small, like stuff you did that you can build in 2 days. And because they're described in the same way, you still have a basic flow and some alternative flows, but there's usually not more than 3 to 4 alternative flows. So it's much easier to build this stuff and to get it out and to test it. And especially for the testers, they love it. So there's some examples, and we use them as the working product. We actually fill up the backlog using these smart use cases in a lot of our projects. So I'm not saying you have to do that, but it's a slightly more structured way of getting to a small unit of work that actually works in an Agile project. And you have to really think about what unit of work you're using. So then the next step is, if you do that, you need to estimate the stuff you're building. And estimation is an interesting process. I do a lot of talks about estimation, and I usually ask the people in the room, how big is your current project? Does anybody have a figure up of that? In what type of points whatsoever, in pizza points or... Oh, you're afraid to say, or it's a government project and it's secret, or... So, 2.5 million, that's probably in dollars, I guess. That's small. Okay. How do you know it's small? No, that's I won't ask that question. But anyway, there's a lot of people that do estimates in, let's say, in hours, or in money, as you would say. And the thing with that is, if you do estimates, for instance, in hours, like I'm going to build this user story and it takes me about 8 hours. You do that? You estimate in hours? What? Days or hours. Yeah, that's the same. The thing is, if you do that, it's your hours. So if you go out of the project, somebody else comes in, they might be slower or faster or whatever. No, not faster than you, but there might be people working at a different speed because they have less experience or don't know the domain of the project or whatever. So speed shifts. And the work items that we estimated at 8 hours might take 10 hours now. So how much longer will the rest of my work items take? And that's a difficult question if you estimate in money or in hours. So what you should do is look at this picture. This is a skyline you're more familiar with than I am. It's the Chicago skyline, if I'm correctly. And you probably, if I ask the same question in Europe, nobody knows. But how big is this building until here? That's good. You know, in Europe, they haven't got a clue. Neither had I when I first looked at this picture. I should have taken a skyline from a European city then. But you know, most people don't know. Actually, somebody looked it up and they said it's 458 meters or something. We use meters. That's but if you don't know that, and you have to suppose you have to estimate the total height of the skyline. You probably don't know that by heart. You might know the height of the big building, but so if you would have to estimate that in, let's say, in feet or in meters, that's very hard to do. If you don't know this building, and it's the same with requirements, there's a whole bunch of requirements out there. Every building is a requirement. How big is the project? It's the same question. And if you would say, well, this building is 458 meters, then you would have to calculate all these other ones too. Oh, and that's really hard. But if I would say that this building, we're going to name this 5. It's 5 points, 5 height points or whatever points you're using. Suppose it's 5. How big is then this building? How many points? 4, right, that's a good answer. And this one, and this one, and this one. See, that's easy. Even with 200 people in the room, it's still easy to do this estimate. And that's the same with requirements. It's very hard to actually predict, we're going to take 10 hours to do this work item, user story, use case, whatever you're using, or feature. But it's much easier to do that on a point scale. And there's some additional benefits to it. You need a second number because this will give you the size of your project or the complexity of your project or whatever you express it in. So in the end, we will have 200 points, whatever points. That doesn't give you a clue about the total amount of money that you need for the project or the total number of hours that you need for the project. So the next step you'll need to do, if you do a relative estimation, is find out how long it takes to do a number of these requirements. Or in this picture, find out for a number of these buildings how big they are. And if you do that, you will have, you can actually calculate. So if this one's 458 meters, and it had 5 points, so 1 point is about 90 meters. If I have 200 points in the whole picture, then I'll end up with something. Sure. Calculus is not my best quality at the end of the day. But you'll have a figure for the size of your project. And the same goes with requirements. Suppose you estimate all of your requirements on a point scale instead of in hours, which is an handy pattern, of course. Then you will be able to take a few of them, or actually implement them, or try to figure out with the team how big they are and how long it will take to implement them, and you can extrapolate the whole project. So this is an easier process of estimation. So always estimating points. That's the big idea. And if you do a lot of projects, we do a lot of projects at Capgemini, you might end up saying, well, the stuff I'm estimating, I want to be able to express that on the same scale. So they should be comparable. And even more, they should be repeatable. If different projects use the same unit of work, I want to be able to compare the unit of work in my first project to the unit of work in my second project. And user stories, you know, I'm not against user stories, but they tend to be sort of apples and pears. Like, I translated these two for you. As a customer service employee, I want to see the audit trail of changes of a customer order. And the other one is, as a customer, I want to see a proper error page when my session is expired. How do these compare to each other? And if you have those user stories, how do they compare to the user stories in another project? Usually, when estimating user stories, you split them up into tasks. I've got a picture of that too. You split them up into tasks, and each of the tasks get estimated mostly in hours. Most projects do that in hours. And the big question is, can you compare user stories from one project to another? Or can you even compare the estimation of user stories in one team to the next team in the same project? And the answer is, sometimes. And as they would say in the Scrum community, it depends. So never estimate in hours. I wouldn't even estimate the tasks in my user story in hours. Of course, we don't use user stories a lot, but we tend to add some more structure to it. This is a diagram that we actually draw on a whiteboard during a project that we said, okay, what's the basic stuff we do with these use cases? Actually, it's not a very good abbreviation, but it stands for Smart Use Case. And I'm not really good at thinking of names, so we said, well, in this particular project, this is actually the activities we might do on this particular use case. So we first come up with the criteria for when it's done. Then we started doing some design, whether that's a user interface related use case, or it's a service, or it's a test. We need to add some test cases to it. We start building the stuff in very different technologies, and then we start testing the stuff, and eventually it's done. So if this is the work we do on a use case, the same goes for any use case in the project. Which means that these different items, these different work items, all go through the same cycle. And if they go through the same cycle, we are much better at estimating and comparing them over different projects. So that's stuff you might be able to do too. And then there's the velocity. So I said, well, if you have the complexity, that's okay, but then you need to get to the speed of your project. So how do you get to a velocity? How do you know what the speed is your project travels at? How many points can you do in an iteration? How do you know that? Well, that sort of depends, but getting it right is really, really important because your project tends to get into a sort of flow. People learn to what they might expect during an iteration or during a sprint, how much work there is, and if there's too little work, some things will go wrong, what I'll explain in a second. And if there's too much work, that's an easier one because if there's too much work, you don't get it done, which means people get demotivated. And that happens really, really fast, especially when you're in, let's say, the first Agile project in a company. Where people don't have the trust that they might have after the fourth project. They will say, oh, we're going much slower. We should actually lengthen our iterations. We should go to 3-week iterations instead of 2 weeks. Or we never get the stuff done. And people get demotivated really quick. We tried it out in a project, actually. not on purpose, but we tried it out. And we had 3 iterations, 3 2-week iterations that we put far too much work in that. And people actually started losing their faith in working in an Agile project. And there was actually some votes going up that say, hey, let's go back to the way we did things before we went Agile. And we had to get them into grip and sort of get them in these 2 instructions, say, no, we'll be fine in the end of the project. It was an 8 iteration project, it wasn't that big. And they sort of got into grip, and then they got into flow, and actually they're now at their 5th project in a row, and they're still going at the same speed, and everybody's happy actually in the project. So you have to get in this flow, and to get into this flow, you will need to know how much work will you be able to do during an iteration. And that's your velocity. So if you estimate in points, the velocity will be expressed in the number of points that you can do per iteration. And there's a second number that's also really important, is how many hours does it take to realize 1 point? And these are the 2 figures that you actually need to find out. And that's hard, especially when it's your first project. You haven't got a clue. So what you do is you take a sample of the requirements that you have, and you try to figure out how much time it will take you to implement those 5 or 6 or 8, depending on how big your project is, requirements, and then, okay, you have that number in hours, so that's the speed we'll start up with. And the good thing about it is, since your iterations are really short, after 2 iterations, you will have very good figures for that. You will have actually metrics that allow you to predict the rest of the project. And then there's the importance of how much work can you do in an iteration. And there's things that can go wrong if you put too little work in your iteration. Being in the US, I know that you guys all work really, really hard in projects. You know, in Europe, we usually work from 9 to 5, that's about it. And we try to keep that speed up, which means for us it's really important to get the right number of points during an iteration. If there's too little work in an iteration, Parkinson's law applies. You know Parkinson's law? Yeah, right, you fill the box. That's good. Parkinson's law says the work you have will fill the time available. Think about that. So what if I do 3 user stories? If I plan 3 user stories for the next sprint, and I could have actually done 5, will you have any time left? And the answer is no. You know what people will do, especially developers? What we do as I'm a developer too, I know how it works. We'll make the stuff better than it's necessary. You know, in Agile projects, you say, good is good enough. And if you have time on your hands, you know what? Are there any Java developers in the room? Oh, good. you know, if you have a bunch of Java developers in the project and they have time on their hands, you know what they will do? They will write a framework. I've actually seen it happen in projects. No matter whether you need it or not, they will write a framework because it's fun writing frameworks. I do that too, and it's actually quite a lot of fun. But that's what happens, you know. The time will get filled with the work that you have, and that's not a good thing because you could have finished much more. You could have finished your project earlier. I'm not really sure that's a good thing if you're just on a time material basis, but you could have been faster. You could have had a shorter time to market. So too low is not good. Also, student syndrome applies. Well, you've probably all been to university or college or whatever. You know what this is, student syndrome? It's the fact that if I don't have enough work, I start thinking, hey, you know what? My exam isn't until next week. So you know what I'm going to do? I'm going to do something else. Go to the beach, do some surfing, whatever, and not do the work. And the same thing applies in projects. In most cases, you won't have your developers or whoever's in the project full-time in your project. We have a lot of projects that have part-time people in it, and they part-time do other stuff, like keeping up older software or be in meetings or whatever they do. And you know what they'll do? They say, if there's not enough work, oh, we can do this in 3 days. So the other 7 days in the iteration, we can do other stuff. And then somebody else comes along and they say, we have a bug in our software. Could you help out? And they say, oh, sure. And they're off for 2 days. And then in the end, when they still have 3 days left to do the work actually appears to be a bit bigger, and they can't finish it. So that's student syndrome. And the way to deal with that, with both syndromes actually, is that apply the right amount of work to your iterations. And if there's too much work, of course, teams will actually, oh, that's a strange word, overlap. That's a typing error I just made. I don't know what I meant by that. Overload, right. That's the... So motivation drops, that's the easy one. So the next thing, and this is one of my favorites. If you look at the way you learn stuff, this is very famous. If you look at Japanese sports or most karate or stuff like that, there's different levels of learning stuff. It's called shuari. You should look this up. This is really good stuff. And the first level of that shu, it says, go out to someone who knows that. It's like in a Karate Kid. He goes out to Mr. Miyomi and whatever his name is, and he says, learn me this stuff. And he gets to wash his car. That is in the original movie. And he just spends the whole day waxing on and waxing off the car. And he doesn't really understand why. Well, this is the first level. When my middle son first started taking up karate lessons, it took him 2 months before they actually could do the first kick. Because first they had to learn how to fall. Because if you fall in the wrong way, well, you can break everything in your body. And that's not the way you should do it. So you learn the basic principles first, just by copying it from someone who's already done that. And that's the level that a lot of people will enter into Agile projects now. They will go to a 2-day course and get a certificate and don't have any experience yet and go into this project. And they will be very rigid in the way that they approach these Agile projects. A lot of strange stuff happens. Like, for instance, this one. They call this a pseudo-scrum meeting. That's where one guy, I'll show you a picture of such a meeting. This is me, and this is a starting Agile project. And to be able to participate in these stand-up meetings or scrums or whatever you want to call them, I actually had to point out to them, hey, now it's your turn to speak up, and it's your turn to speak up, and et cetera, et cetera. And that's what sometimes is referred to as a pseudo-scrum meeting. Who cares? I don't. Particularly, and this is the way you should do it. Actually, I once got the advice from a certified Pokemon trainer or whatever he was, and he said, well, if this doesn't work like that, you should pass a token between the people. We're not in kindergarten anymore. This is not kid stuff. This can be a good stand-up meeting too. There's no way that you actually have to be like that. This works too. You don't have to be very rigid about it. Or for instance, like with the task board. This is a typical Scrum project task board. What if I have additional stages to that? Is that so important? We have a number more. We have a lot more. We have like design, realize, test, done, and rework is here. There's nothing wrong about it. Still, I had someone who's just had training. I'm not going to tell you which training, because it was a very good training, by the way. They learned how to rip off Post-its from a blog, etc., etc. And he said, well, this is not a good task board. You're not doing an Agile project. I said, what? And they said, this is just as Agile as your task board that shows up here. There's no difference. It's the way you get these Post-its from left to right and the stuff you do with it. But this is not wrong and this is not correct. They're both correct. It depends on the project you're doing. And there's nobody telling you actually that you actually have to do it like this. So if your project has more stages or even more, this one comes from my current project, that doesn't mean it's not an Agile project. Actually, I put up this picture. I took it with my phone. I still have a Windows 6 phone, so it's not a very high resolution. And there was a lot of stuff out here in testing. And actually, I put up this picture because in this project, at this point in time, the tester that I had in my project, the dedicated tester, he was on holiday. And then a colleague of mine came up and he said, well, that's another principle that people learn, is that people should cover each other's work. So if the tester goes on holiday, somebody else should do the testing. Well, you might be able to do that, but I'm not going to get my developers, my very highly trained C# developers, to do testing. Not because testing is silly stuff, because it's a totally different discipline. It's different work. It's not always possible to do somebody else's work. I have SAP developers in my teams. They cannot write C# or the other way around. Or for instance, what if my developers go on holiday? Do I make my testers write C#? Hopefully not. So it's not wrong to have it like this. It's not wrong to be a bit different than what you think Scrum should do, or XP or Kanban or whatever approach you're following. There's no wrong or right in here. I just got a phone call from an account manager this morning. He said, well, I have this developer, and it was a tester. He said, I had a tester. Could he also, is it allowed, he said, for the tester to also act as an analyst in the project? And I said, what do you mean, is it allowed? Well, according to Agile. And I said, well, according to Agile, there's no rule for that. And he said, no rules? He was used to doing rational unified project or whatever. And, and he said, oh, there's no rules. I said, no, if he can do that, why not? So get rid of all this what I call Scrumdamentalism. It's not that I'm against Scrum, it's just it's the most popular and it alliterates really well. So there's a lot of people saying really strange things. Like people saying, sprint should be 4 weeks, not 2. Why not? Who cares? Who actually says this? There's nobody out there in the Scrum community that actually says this. Or like, you cannot use modeling tools in an Agile project. That's strange. We use a lot of modeling tools. Why not? So it's not forbidden to do things differently. Or I had this one in Belgium once in a project. They said, you must pair program. That's cool. Pair programming is good, but I don't have to do it all day. I get pretty fed up with this other guy sitting next to me on my desk. And that's allowed. It's allowed to not pair program. It's a good technique, but it doesn't have to be mandatory. So what is it with these Agile teams? There's a nice size to Agile teams. Usually when I look at projects, they have teams that are around to 8 to 12 people. And that works really well, especially when you have a lot of different roles in your team. And it's called a 2-pizza team. It's like the team you can fit with 2 American-sized pizzas. I think it was coined by Amazon. So that's a good size of a team. And especially when you have really strange teams. Like you probably are mostly in, I don't know for sure, but mostly in .NET projects. So am I. But sometimes you do different projects, like projects that have 2 business analysts in the team. First you have to find out what these guys actually do. They draw up diagrams. They make up diagram techniques too, by the way. And then there's information analysts. They usually use UML techniques. And then there's a lot of SAP guys in there, which this team comes from the first SAP project I did. It's about 2 years ago. And I haven't actually ever seen an SAP ABAP developer. Have you ever seen this code? This is crazy code. It's even worse than VB. And we had a .NET developer, and the .NET developer, you think he would write the front end, like in ASP.NET or ASP.NET MVC or whatever framework you're using. He wrote services for an application that was running somewhere in the back end, a .NET application that they had in the back somewhere stored in a closet or whatever. And there was 2 testers in my team, luckily. There was a Scrum Master, it was sort of mandatory, and I was the Agile coach in there. So it's a very strange mixture of things. So you have to find out how to get these people work together in your project. And so you can see that even with these very strange roles, you can actually work together. It's like the whole picture from Winston Royce packed into a very small unit. And it's not just having a bunch of developers, a product owner, and a Scrum Master in your project, or a coach as they call it in XP. You have to find out a way to get all these people work together. Like here we're estimating the requirements in our project with the tester, the CRM consultant, the middleware developer, the ABAP developer, and me, and there were some other guys like an enterprise architect. What do these guys do in project anyway? And or girls in this project, by the way. And you estimate with the whole team, all these roles together. And you come up with 1 figure for that, not 5 points for the tester and 3 points for the developer. No, 1 figure for that. Or design with the whole team. Here's a tester. He's the tester in our project. And he actually leads the design sessions for the use cases. Why? Well, simply because he has a very structured mind. Most testers have that, and instead of developers like us, we look at the world a bit differently than testers do, or the other way around. He had a very structured mind and very rigor about that. So he led the design sessions, together with, in this case, the middleware developer, for instance. And here's the tester with the ABAP developer. They're sitting together. Here's the test cases he just wrote, and they're sitting together testing this stuff against SAP. And that's different. You might not expect that in your regular project, but you will see this in the future because Agile projects will grow and grow. And whoever is responsible tests and accepts the use cases in this case. In this case, it was the tester who accepted it because this is actually a service running against SAP CRM, and it in came an XML document and out came an XML document and some error messages that might come out, and he's much abler in doing this testing than the end user would be or the product owner would be. So we had him accept the use cases in this case. So you have to, the basic idea about these pictures is that you have to tweak your process to the team that you have. It's not like we follow this process like Scrum or XP or Smarter FD or whatever. You have to tweak it against whoever's in the project. And it can be very different from project to project. For instance, this project, we had the enterprise architect. She had to approve all the use cases that we were doing. So each time we did the design for a use case, he said, well, I want to be able to look into it, review it, and approve it, or whatever I'll do with it. And we said, okay, that's cool. And how long are you going to take to do that? And she said, well, I'm very busy right now. And I guess I will have it done in about 3 weeks for you. I said, well, the iterations are 2 weeks, and we will be done with this use case in 1.5 weeks or so. And then we said, okay, we had to find a way of dealing with that. And that's the good thing about an Agile project, is that you get into this retrospective evaluation at the end of each of these iterations. And you can actually say, hey, we need to get her involved more. So what we did is we invited her to do the design sessions with us. And we said, okay, do the design with us, and at the end of the design session, you're allowed to say whether it's okay or not. And she did that, and actually she enjoyed that. And I visited this customer a few weeks ago, and she was actually now in charge of writing the use cases for the project. And she liked it a lot. So you have to find a way of getting all these people into your project. And then some small ones at the end of the presentation. Stand-up. I guess all of you are using stand-up meetings, or scrums, or whatever you call it. Who isn't? Oh, that's good. You know, and stand-up means, it seems so easy. Get together, 10 o'clock, set a boiling clock and say, well, 50 minutes and we're done with the stand-up meeting. And there's a lot of things that can go wrong in stand-up meetings, like people who don't show up. Yeah, I have a developer in my team, and he's a very nice guy, but he lives in the Netherlands, and his girlfriend lives in Barcelona, which means they're usually in touch through MSN. And he does that at night. And actually, the strange thing about MSN is that it takes a whole lot of time. And he usually doesn't go to bed before 3 o'clock in the morning, which means he doesn't show up at the project before 11. But he's my lead developer in my project, so I have to take him into account. So what do? Well, there's a lot of stuff you can do. You can actually move the meeting after lunch. That's an option. Or another problem that arises is that we had, in this project where this picture comes from, we had our stand-up meetings at 10 o'clock. People arrive at work around 9 in this company, which means they have about an hour until the stand-up meeting comes along. And what do they do in this hour? Which is usually a productive hour in your project. Which it wasn't, because they say, oh, we have an hour, so I can just read my email. And they start doing other stuff in that hour. So we moved the stand-up meeting from 10 o'clock to 9:15. So when they come in at 9, or when they miss the bus, come in at 9:15, there was no way that they could start reading their email. So it saved us an hour for each of these persons in this project every day. Just taking this very simple measurement into account. And other things can go wrong. This is, of course, a very good stand-up meeting. Here's people standing up. Here's the project manager. And here's the other guys in the project. And they actually stand up. We put up the dashboard here, or the taskboard, or whatever you call it. So this is a good one. And they usually succeed, and usually get people around. Here's part of the team sitting. And there's a lot of people say, no, you have to stand up. Except when you're handicapped or whatever, but otherwise you have to stand up. But this works really well, because this is a team that is, you can see it, by the way, how many people are there in a few square feet. It's a team that trusts each other, that knows how to work with each other, that's been acquainted, and they work really well, so there's no reason really to stand up. It can also go wrong. It can also go distributed, by the way. I didn't know I put this slide in last minute. So what do you do in distributed projects? We do a lot of projects that involve people, for instance, in India or in Spain or in Pakistan or whatever. And you have to do the same stand-up meeting in your distributed project. So you have to get some sort of video conferencing out here. And this is a very cool setup. This is a desk in the office I usually work in, and it's a wooden desk. In India, they have exactly the same desk. So the good thing is, there's a TV screen on there with a camera on it, and they have exactly the same setup. Which means if you're around this table, if you're sitting here, it has a bit of look and feel about if you're on the same table. That is, the image is sort of like it, not the sound. Because the sound is slowed down, there's some latency in there, and that makes it difficult to do this stuff. But stand-up meetings also, if you do them on-site, they can also go wrong, like this one. This was a very hard situation. You know what you have here? This is a bunch of developers, really good developers, a couple of MVPs in there too, and there's the project manager for this project. And you know what's the difference between him and him? He's wearing a tie. So he's a better project manager. No, he's not. But he was very, he was not very senior, this guy. So what actually happened is that he organized the stand-up meetings where the people had their desks and where they're working. And these stand-up meetings, which I now refer to as sit-down meetings, they got longer and longer and longer. Because why? Well, people, they just, he started reading his email or typing some stuff because I still have to finish some stuff and etc. This didn't work. So actually I advised them to move out of this room during the stand-up meetings. So we went to the coffee machine. We put up the dashboard, we moved it from this room to next to the coffee machine, and we said, well, move the stand-up meeting just to that location. And they did, and it improved. And people actually participated in the stand-up meeting, and actually the atmosphere in the project sort of improved. So what you see is that by doing very simple things, what you usually come up with during your evaluation or retrospective meetings at the end of your iterations, you can still improve and tweak and twine your process. So, one more. Oh, underestimating testing. Yeah, I have to do that, of course. Am I still on time? Not yet. Sorry about that. I still have a few slides left. I'll go through them quickly. It's only 7 left. You know this figure? This is this figure is or this diagram. It's the reason that you should test from day one. This is Boehm's law, and it actually says the longer you wait by solving a bug or finding a bug, the more time it takes to solve it. So you can better find it here. And this is the main reason you should test from day one in your project. And testing is actually much more than just doing unit testing. As a lot of developers, we do unit testing, we test. Yeah, you test your code, and whether your code works correctly, and whether it will work correctly over months and months and months to go. And that's a very good technique. I like it a lot. But there's more to it. Testers do different stuff in projects. They test functionality. They test whether the software you build actually does what the end user wants. And that's different. That's not testing whether your code is correct. It's testing whether the right functionality has been built. And here's an example of how you can do that. For instance, we do, this is again for my current project, and we tweaked and twined the process. We do developer testing. After one developer finishes code, it goes on to the next developer. He does a review on it, he tests the code, see whether there's still some bugs in there or exceptions that get thrown or whatever stuff's out there. And once that's done, this other developer puts it into testing. And here comes the tester. So here's the actual tester. And it's a guy with a very different discipline, and he tests the functionality. And then it goes on to the end users, and they do some formal acceptance. That's when, for us as a company, it's done. So it's now in the hands of the customer. Or either it can go from any of these stages into rework, and then it goes back into design, etc., etc. So there's a cycle that involves a lot more than just doing unit testing. So be aware if you're in an Agile project, even though Scrum or XP or whatever Agile approach you're using does not tell you to do testing explicitly, it's very important. I would certainly advise you to have a certified tester or whatever they are, a real tester, not a developer who also looks at the web pages, but a real tester into any Agile project. That's a very strong advice I can give you. So that's about it. Takeaways. It's not the methodology that does the work. It's you that do the work. It's the people in the project. So you have to tweak and twine the process you're using, whether that's Scrum or XP or any of these other processes. Adhere to these Agile principles like working in multidisciplinary teams, use short iterations, use a small unit of work, test early, deliver early, stuff like that, plan continuously, evaluate, and don't get religious about any of these Agile approaches. Don't reinvent the wheel too. And that's about it. And then you can do really good Agile projects. Okay, sorry about the 5-minute delay. By the way, if you like the session, don't forget to fill out your evaluation forms.